The vastness of the cosmos holds secrets that transcend our current understanding of space, time, and the very fabric of existence. It's in the most remote corners of the universe where the James Webb Space Telescope, JWST, is uncovering mysteries that are shaking the foundation of modern astrophysics and cosmology. What we once took for granted, such as the nature of time, the origins of the universe, and the validity of the Big Bang Theory, may all be up for debate. Now, as you prepare to dive into this cosmic enigma, brace yourself for a mind-bending revelation: time might not exist as we know it. The James Webb Space Telescope, a cosmic game-changer. When NASA launched the JWST on December 25, 2021, it marked a new era in space exploration. Dubbed the successor to the Hubble Space Telescope, the JWST is equipped with advanced infrared instruments that allow it to peer deeper into space and further back in time than ever before. Its capabilities have not only opened windows into the early universe, but also raised unsettling questions about the very laws that govern our reality. It's as though JWST is more than just a telescope; it's a time machine, capable of capturing light that has traveled across billions of years, from galaxies that existed shortly after the birth of the universe. What sets the JWST apart from its predecessors is its unprecedented sensitivity and resolution. Hubble revolutionized our understanding of the cosmos by allowing us to see distant galaxies, nebulae, and supernovae, but JWST takes it a step further, revealing objects and phenomena that were previously hidden. Through its powerful lens, we've begun to glimpse the universe as it was over 13 billion years ago, so ancient that light from these galaxies took almost the entire history of the universe to reach us. But here's the kicker: these galaxies don't behave as expected. The JWST has revealed anomalies that challenge the Big Bang Theory and the idea that time flows in a straight line. What if time, as we understand it, is a mere illusion? The time-bending riddle of the universe. For decades, the Big Bang Theory has been the cornerstone of cosmology, the go-to explanation for the origin and expansion of the universe. According to this model, around 13.8 billion years ago, the universe began as a singularity, a point of infinite density and temperature. From this explosive event, everything expanded outward, with galaxies moving farther apart over time, much like raisins in a rising loaf of bread. As space expanded, so did time. In this framework, time flows in a linear fashion, marching ever forward from the moment of the Big Bang. However, the JWST has captured data that doesn't quite fit into this narrative. Distant galaxies, those from the early universe, appear smaller, smoother, and older than they should be according to the standard model. What's more, there are far too many of them. Rather than supporting the idea of a universe expanding from a central point of origin, these galaxies suggest a more static, non-expanding cosmos. Imagine the universe as a trampoline net. In the traditional model, we're supposed to see galaxies farther away getting stretched as the net expands, but instead, these distant galaxies appear to be just as large and developed as the ones near us. It's as though the net was never expanding to begin with. One of the most perplexing findings is the apparent age of the stars within these galaxies. According to the Big Bang Theory, stars should be relatively young in these distant, ancient galaxies, yet the JWST shows stars that seem far older than expected, some as old as 1 billion years. This creates a paradox because, according to the Big Bang, the universe itself is only 13.8 billion years old, and these galaxies are seen as they existed just a few 100 million years after the supposed explosion. Moreover, these galaxies are pristine, with no signs of the violent mergers or collisions that the traditional model predicts should have shaped them. Instead, they are smooth and neatly structured, resembling nearby galaxies like our Milky Way, which have had billions of years to evolve. If these galaxies are not the result of cosmic collisions, then how did they form? And more importantly, if they already existed in this form so soon after the Big Bang, what does that mean for the theory itself? These findings have thrown the scientific community into turmoil. Astrophysicists like Alison Kirkpatrick of the University of Kansas have openly expressed their shock and confusion, describing sleepless nights spent questioning everything they thought they knew about the universe. The problem isn't just that these galaxies exist, but that their very existence threatens the validity of our most cherished cosmological models. Time is an illusion, the block universe theory. The implications of JWST's discoveries go beyond the expansion of the universe. They touch upon one of the most fundamental aspects of reality, time. For centuries, we've perceived time as a linear sequence: past leads to present, and present leads to future. But what if time doesn't actually flow? What if time, as we experience it, is merely a construct of human consciousness? This idea isn't as far-fetched as it might seem. Physicists have long debated the true nature of time, and many have proposed that it might not exist in the way we think it does. One of the leading theories in this debate is the block universe model, an idea that stems from Einstein's theory of relativity. In Einstein's model of spacetime, time and space are not separate entities but rather part of a single four-dimensional continuum. According to this view, time doesn't flow like a river. Instead, all moments, past, present, and future, exist simultaneously in a block of spacetime. From this perspective, every event that has ever happened or will happen is already out there, just waiting to be observed. It's only our perception that creates the illusion of time moving forward. MIT physicist Max Tegmark describes it like this: we could view our reality as a three-dimensional place where stuff happens over time, or as a four-dimensional place where nothing happens, where everything just is. If it's the latter, then time is an illusion, because nothing really changes. In a block universe, everything, from the birth of stars to the fall of civilizations, is happening at once. The past isn't gone, and the future isn't yet to come, they both exist right now. Julian Barber's Now Moments. British physicist Julian Barber has taken the block universe idea even further. In his theory, reality is composed of a series of distinct now moments, like individual frames in a film reel. Each now is a separate, self-contained snapshot of the universe, existing independently of what came before or after. According to Barber, the past is simply a collection of memories, and the future is just a projection of what might happen next. Barber argues that time itself is an illusion created by our consciousness. The feeling of the passage of time is nothing more than the way our brains store and retrieve memories. In his model, there is no past or future, only a vast landscape of nows. He calls this landscape Platonia, where every possible configuration of the universe exists simultaneously. In this timeless realm, every moment, every experience, and every possibility is already there, waiting to be experienced. What's particularly intriguing about Barber's theory is how it challenges our deepest intuitions about causality. We believe that events happen in a sequence, cause leads to effect, but in a block universe or Platonia, there's no such thing as before or after. All causes and effects exist at once. From this perspective, time travel might not be about moving forward or backward in time but rather about shifting from one now to another. The Big Bang, on shaky ground? If time is an illusion and the universe isn't expanding, then what does that mean for the Big Bang theory? The recent findings from JWST suggest that the Big Bang might not be the definitive origin of the universe after all. The galaxies observed by JWST, with their mature stars and stable structures, defy the notion that everything began as a chaotic explosion. Instead, they point to a more complex and perhaps eternal universe, one that may have always existed in some form or another. The Big Bang theory has been remarkably successful in explaining many aspects of the universe, such as the cosmic microwave background radiation and the abundance of light elements like hydrogen and helium. But it's not without its flaws. For example, the Big Bang theory has consistently struggled to explain why the universe appears so uniform on large scales and why we observe such a vast number of galaxies when, according to the theory, there simply hasn't been enough time for them to form. More troubling are the discrepancies between the predicted amounts of certain elements, like lithium, and what we actually observe. The theory also struggles to account for the existence of massive cosmic structures like superclusters and walls of galaxies, which are simply too large to have formed in the time available since the Big Bang. Recent research suggests that the Big Bang theory may have gotten up to 16 key predictions wrong, from the density of matter in the universe to the amount of helium present. While the theory correctly predicts the abundance of deuterium, a form of hydrogen, it overestimates the amount of helium and lithium by significant margins. These inconsistencies have led some scientists to question whether the Big Bang model is truly the best explanation for the origin and evolution of the universe. A new cosmic paradigm? As we grapple with these revelations, it's clear that our understanding of the universe is far from complete. The discoveries made by JWST are pushing the boundaries of what we thought was possible, challenging the most fundamental assumptions about time, space, and the nature of reality. If time is an illusion, and if the universe didn't begin with a singular Big Bang, then we may be on the cusp of a paradigm shift as revolutionary as Einstein's theory of relativity. This isn't the first time in history that humanity has had to rethink its place in the cosmos. In the 16th century, Copernicus proposed that the Earth wasn't the center of the universe, and this idea sparked a scientific revolution. In the 20th century, Einstein's theory of relativity overturned centuries of Newtonian physics. Now, with the findings from JWST, we may be facing another turning point, one that could change how we view time, space, and the universe itself. The road ahead, unraveling the mystery. What lies ahead is an exciting and uncertain journey. As scientists continue to analyze the data from JWST, new questions will emerge, and new theories will be proposed. Will we find that time is indeed an illusion? Will the Big Bang Theory be replaced by a new model of the universe, one that better accounts for the observations we're now making? One thing is certain, the universe is far more mysterious and wondrous than we ever imagined. With each new discovery, we are reminded of how little we truly know. The cosmos is still hiding its deepest secrets, waiting for us to uncover them. As we stand on the edge of this new frontier, the possibilities seem endless. In the end, the search for answers about time and the universe is as much about understanding ourselves as it is about understanding the cosmos. As we peer deeper into the vastness of space, we're not just discovering the nature of reality, we're also confronting the limits of human knowledge and the infinite potential of human curiosity. And that, in itself, is the most awe-inspiring journey of all.